with movies like The Martian, Guardians of the Galaxy, Star Trek, or maybe books like Project Hail Mary or Dune. Now, see, the thing that ties all these works of fiction together is their real-life fascination with space. And these stories and thousands of others share their love of space with audiences from around the world. And while many of them may include fanciful civilizations or crazy future technologies, they're all rooted in real science, real space exploration. And that's what I want to talk about today. 3 NASA missions that you should know about because they are pushing humanity further into space and further into the future. First mission we're going to talk about today is the Artemis mission, then the James Webb Telescope, and thirdly, the Mars Sample Retrieval mission. So let's jump right into NASA's lunar mission, Artemis. Artemis is NASA's ongoing attempt to put people back on the moon, including the first woman and the first person of color. So now Artemis' mission goals are to further explore the lunar surface, to collaborate with international and commercial partners, and to establish a long-term human presence on the moon. This all comes from NASA's Lunar Exploration Program Overview that was officially published in September of 2020. The whole idea of the Artemis mission is based on the idea that when we explore the moon, and if we know more about human space exploration, that can be the first step to putting a human on Mars. And this process is ongoing. Artemis 1 was an unmanned test flight that was launched and orbited around the moon to test to see if it could safely return back to Earth. It safely made its splashdown in the Pacific Ocean. So Artemis 2, which is set to launch in November of 2024, was approved. So to do all this, NASA partnered with the European Space Agency, the Canadian Space Agency, and the Japan Aerospace Exploration Agency, and various other commercial partners. Without this collaboration and communication, the Artemis mission would not be able to do as much as it is right now. It would not have the vast ability to explore and to pursue space exploration as it is right now. So while the Artemis mission is sending humans further than they've ever been before, the James Webb Telescope is helping humanity look deeper into space than ever before. So let's shift our focus to about 1 million miles away where the James Webb Telescope currently orbits the Sun. So for a little bit of background, the James Webb Telescope started out as an idea in 1989. And yes, you did hear that right, 1989. It was supposed to be the successor to the Hubble telescope. It's meant to be a bigger telescope that can detect infrared light. And the reason for that is because infrared light can see deeper into space than ultraviolet light or visible light, which is what Hubble telescope uses. So 2 devices that are on the James Webb Telescope to detect infrared light are the near-infrared imager and the slitless spectrograph. All this information came from the official James Webb Telescope website, which is run by the Associated Universities for Research in Astronomy, aka AURA, which has been established in the astrophysics and astronomy communities since 1957. So the delicate instruments on the James Webb Telescope are a direct product of thousands of people collaborating and communicating for over 30 years. Over 13 countries worked in the production and assembly of the James Webb Telescope, and it was a direct partnership with the European and Canadian space agencies and NASA. So the Webb Telescope can capture light that is billions and billions of years old, which means when you're looking at just a simple picture from the James Webb Telescope, what you're really looking at is a tiny snapshot of the past. Now, what that means is that the Hubble telescope can look into the past and can provide scientists and astronomers with information we've never dreamed about before. We can learn how stars are formed, how galaxies are formed, how black holes work, and how our universe will evolve, how the universe works. So let's bring it back to Earth for a minute. Or maybe I should say Mars, because the next NASA mission I'm going to tell you about today is a Mars sample return mission. The ultimate goal of the Mars sample return mission is exactly how it sounds: to bring Martian samples of the Earth, dust, soil, regolith, all that, back to Earth to be studied. Now, we have sent rovers and satellites for years to Mars, and all of that data has been extremely important to the understanding of the red planet. But that information is just not nearly enough to send people to Mars, and that's what we need. So if we were to bring samples of Mars to Earth, we can use our extremely delicate, efficient, and precise equipment to study Mars and to gain a better understanding of the planet. But this project has been posed for decades, and it's only just now getting the attention and funding it deserves. And this project is going to take years and years to put together, and even longer to see through. If the current projections for this project are accurate and absolutely nothing goes wrong, which is unlikely, but if nothing goes wrong, we are estimated to get Martian samples in 2033, over 10 years from now. So, you may be sitting here wondering, why do I care? I don't care about the moon. I don't care about Mars. I don't care about a big old telescope in the sky that's a million miles away. So, if you take away the fact that this whole thing is just extremely fascinating and a huge step for humankind, well, you are left with the fact that many daily technologies that we all use are a direct product of space exploration. Things like satellites, LASIK, invisible braces, firefighting equipment, enriched baby food, and even cordless vacuums are all technologies that NASA or other space agencies developed to solve problems that other people commercialized on and gave to the public. So now that you know why it's important, let's recap. The three NASA missions that we talked about today are the Artemis mission, the James Webb Telescope mission, and the Mars sample return mission. So my call to action today is to be curious. The thing that drives scientists to spend their lives studying, the thing that drives humanity to reach beyond its boundaries and explore everything we can get our hands on, is curiosity. And each and every one of you have it. So the next time you have a question, ask it. The next time you wonder why or how something works, try to figure it out. Because that curiosity, that why, who, what, when, where, that is what's going to drive humanity further into space and further into the future. So with that, I thank you.